So on this section, 6.5, we're still simplifying radicals, but we're doing operations with radicals. We are going to be adding, subtracting, multiplying, even distributed property, even FOIL method with binomials that involve radicals, like square roots in this case. So let's just go through. I already made another video with a different class going through a whole lesson, but I found that people got bored. So I'm just going to jump right into the homework here so you guys could follow along and understand how to do some of it, and then you do the ones that I don't do. So on number 9, we've done simplifying radicals before. We're going to split that third root to each of the terms. We have the third root of 8, we have the third root of g to the third, and we have the third root of k to the 8th. Okay, so the calculator will do this for you, or you could simply think what times itself 3 times will give you 8. The answer is 2. And we learned when we simplified radicals that any radical could be changed to a rational exponent, an exponent that's a fraction, right? So it's always going to be the power over the root. So 3 divided by 3 is 1, so you do end up with just g to the 1. And over here on this one, I want to rewrite it k to the 8 divided by 3. Again, any radical value could be rewritten as a rational exponent, an exponent that's a fraction, and the power goes up as a numerator, and the root, goes as a denominator. So you have k to the 8 thirds, which is an improper fraction. So what we need to do is actually divide 8 by 3, and that'll go in 2 times, and you'll have a remainder of 2. So what I'm trying to say is that the k to the 8 thirds becomes k to the 2 and 2 thirds, correct? Is everybody with me? Or are you guys already bored? Okay. So the k to the 2 and 2 thirds, you could use rule 1 and split the base. The k, you could write it as k, and you're going to put the 2 on the first k, so that'll be k squared, and you're going to put the 2 thirds on the second k. Now, if they told you leave your answer in exponential form, then this would be your answer. But the answers on the back are in radical form. So anything that has a rational exponent, change it back. This is going to be the third root because the denominator is 3 of k squared. So you're going to have your final answer of 2g k squared, third root of k squared. So that's your final answer for number 9. What do you think? Number 13 is way more challenging. By the way, you obviously do not have enough space on this worksheet. I don't even have enough space, and I could zoom in a lot. You guys are going to probably have to write this separately in your notebook. Number 13, we're going to divvy up this radical into each of those terms. I want to put the radical on the fraction 1 over 128. I want to put the radical on the c to the 4th and the radical on the d to the 7th. So each of these become like a separate problem to do in itself. So when we have the square root of 1 over 128, you're going to have to split that root, and you'll have the square root of 1 over the square root of 128. Now, since we are dealing with a square root, we would like a perfect square number, right? And 128 could be rewritten as 64 times 2. So you really have 64 times 2, and when you split that root, you'll have 8 with the square root of 2 in the denominator. Now, up on top, we have the square root of 1, and we end up with 1 up on top over 8 square root of 2 in the denominator. Now, there is one detail about radicals. You can't leave them in the denominator. You can't leave a square root in the denominator, so you'd have to get rid of whatever root you have in the denominator by multiplying it by that same square root value, both top and bottom. So on this first part of our answer, we're going to end up with 1 times the square root of 2, which is 1 square root of 2, or just square root of 2. And on the bottom, you're going to end up with 8 times square root of 2 times square root of 2, which is what? What's square root of 2 times square root of 2? And what's square root of 4? So you really have 8 times 2, right? And 8 times 2 is 16. So that's barely this first part of our answer. This is a challenging one. That's why I'm explaining it. Not only that, you could, if you wanted to, place that 1 that was originally in front of the square root of 2. That way you could split it and make it look like this. You could make it look like a 1 over 16 times the square root of 2. I know, that's kind of weird. But let's keep going here. The square root of c to the 4th, power over root. You have 4 divided by 2. So what do we end up with? The square root of c to the 4th, that will be c squared. And last but not least, the square root of d to the 7th, that's going to be the power over the root. So that's really going to be d to the 7 divided by 2. 7 divided by 2 is 3.5, right? So d to the 3 1/2 power, which means that we are going to use rule 1 of exponents and split that d into 2 separate d's. D to the 3 times d to the 1/2. Do we understand that? How to change a mixed fraction as the exponent. Right here we have a mixed fraction as an exponent. Split the base into 2, put the 3 on the first one, the 1/2 on the second one. Yes or no? Mm-hmm. Okay, good. Now, the d to the 3rd, that's just d to the 3rd. But what's d to the 1/2? You can't really do that, so let's rewrite it back in radical form. So what's d to the 1/2 power? The square root of d, right? So let's think about what we have here so far. We have 1/16 that we're going to put right next to the c squared and the d to the 3rd. So let's put all these 3 right next to each other. You have 1/16 c squared d to the 3rd, and then we're going to put the square root with that square root, multiply them together. You're going to have the square root of 2 with d. Ladies and gentlemen, that should be the answer that you see on the back of your page. So again, that's a lot of work for such a little bit of space. You might have to write it separately in your notebook. We're also going to be distributing. Now, what do I mean by that? Let's take a look at 23. Why not? 23. So it's kind of like if you had a binomial times a binomial and you just distribute one at a time. So let's do that. The square root of 5 times the square root of 5 is what? Yeah, I want to show my work, the square root of 25, and later it'll become 5, right? And the square root of 5 times positive square root of 2. A positive times a positive is a positive, and square root of 5 times square root of 2 is what? Square root of 10, all right? And then let's distribute negative square root of 6 times a positive square root of 5. A negative times a positive is a negative. Square root of 6 times square root of 5 is square root of 30. That's right. And last but not least, negative square root of 6 times positive square root of 2. A negative times a positive is a negative. Square root of 6 times the square root of 2 is the square root of 12. Okay, so the question is, could we simplify anything? Well, we already know that the square root of 25 is just 5. So far, so good. Could any of these be broken down further? 10 is not a perfect square number. You can't rewrite it with multiplication to get a perfect square number. Same thing with 30. You can't do it. Negative. Yeah, this one could be rewritten. So yeah, 12 could be rewritten as 4 times 3. That way when you split the root, you'll have 2 square root of 3, and it will have a negative sign right in front of it. So negative 2 square root of 3. But I believe that's all you could do. Your final answer should be, I think, 5 minus 2 square root of 3 with the plus square root of 10 minus square root of 30. Could you check the back for me? That looked too ugly to be the right answer, but it is the right answer. Again, you're supposed to try and simplify the square root of 30, which you can't. You're supposed to try simplify the square root of 10, which you can't. Now, if you did have another that would simplify to the square root of 3, you'd be able to combine them because they'd be like terms. So we're going to do the same for 26, but you're going to have to write it twice. Should we do 26, or should we jump to fractions that have radicals in them? 26, why not? All right.
30.
All right, we'll get to 30 right now. Let's do 26 first. Let's rewrite it, that binomial 2 times. After all, that's what the power of 2 means, for you to rewrite this 2 times, multiply it with itself 2 times. So you write it twice, and then you do distributive property. Let's begin with the square root of 3 times the square root of 3. What is that? Let's show our work and write the square root of 9 just for a little while, right? And then the square root of 3 times 4 square root of 7. It's kind of like if you had an invisible 1 in front and you multiply that 1 times 4, you're going to get 4. But then when you multiply the square root of 3 times the square root of 7, what do we get?
21.
Square root of 21. Okay, so now let's distribute the 4 square root of 7 times that 3. That's like if there were 1 right there, you'd multiply the real 4 with the real 1. 4 times 1 is 4. So you're going to put plus 4. And again, square root of 7 times square root of 3 is the square root of 21. And last but not least, 4 square root of 7 times 4 square root of 7. What do we get there? 16 and square root of 49. That's right. And now let's actually simplify these perfect square values, like the square root of 9, that becomes 3. And over here, instead of 16 times square root of 49, we're going to say 16 times 7, which will be 7 times 6 is 48. That'd be 118. So we have plus 118, 112. Whoops, couldn't do it in my head. Sorry. And the middle values, the positive 4 square root of 21 with another 4 square root of 21. It's kind of like saying I have 4 of these radicals plus 4 more of these radicals. I have a total of 8 of those exact radicals plus 8 of those exact radicals. So the only other thing that I could do is actually combine the numbers with the numbers. The 3, combine it with the 112, and we'll get a final answer of 115 plus 8 square root of 21. Now, of course, the square root of 21, you're supposed to try and simplify it, but you can't, right? 21 is not a perfect square number. You can't rewrite it with multiplication to get a perfect square number. So this should be your answer on the back of your worksheet. Which other one would you like to see? Somebody said 30? Anytime you have a fraction with a radical in the denominator, you have to get rid of it by multiplying by its conjugate. You guys kind of remember that from complex numbers, where you couldn't have a binomial that had an I down there, so you'd have to multiply by the same binomial but with a different sign in the middle. Check it out. I want to multiply the 4 plus square root of 3. I want to multiply that by the conjugate 4 minus the square root of 3. And what you do to the bottom, you must do to the top, 4 minus the square root of 3. So when I multiply a binomial with its conjugate, the radicals disappear. It works out nice and beautifully. Now that's not going to happen on the top, but on the bottom, the square roots will disappear. Let me show you. On the bottom, where you go 4 times 4, you'll get 16. Where you go 4 times negative square root of 3, that'll be negative 4 square roots of 3. And then when you distribute positive square root of 3 times 4, that'll be a positive 4 square root of 3. And then the positive square root of 3 times negative square root of 3. A positive times a negative is a negative. And the square root of 3 times square root of 3 is the square root of 9, which will later become just 3. So watch the magic happen right here. When you multiply a binomial by its conjugate, when you combine like terms, this one and this one are exact opposites. They eliminate, they're gone. And not only that, the square root of 9 is actually 3. So I really have 16 take away 3. So my denominator portion of my answer is going to have the denominator 13. Because 16 take away 3 is 13. Now we still need the numerator. So this is a long process to get these done. I apologize, but we have to be good at it. 5 times 4, let me get some more space up here. 5 times 4 is 20. 5 times negative square root of 3, that's negative 5 square root of 3. Positive square root of 3 times 4, that's positive 4 square root of 3. And positive square root of 3 times negative square root of 3, that's negative square root of 9. Now, because these were not conjugates, you end up with radicals still. The middle values don't cancel out, right? If you combine this negative 5 of those square roots of 3 with those positive 4 of those square roots of 3, you end up with negative 1 of those square roots of 3. You don't even really need the 1. You could just put minus square root of 3 right there. And the square root of 9 back here, that's really 3. So you really have 20 take away 3. 20 take away 3 is 17. So this is my answer for the numerator. 17 minus the square root of 3. 17 minus the square root of 3. And if you wanted to, you could split up that denominator of 13 to get your final answer. I mean, this is absolutely 100% correct. But if you split it up, you could do that as well. So either answer is correct. How did they write it in the back of the worksheet? Did they write the first one or the second one? First one? Okay, cool. So just in case there's a multiple choice test, midterm or final, they might write it separate, but this is the correct answer right there.
Conjugate.
Conjugate, yeah. On 28, you want to multiply by the conjugate. So what is the conjugate?
Square root of 5 plus 2.
Square root of 5 plus 2. And you have to do that to the top as well. So you're going to multiply by the square root of 5 plus 2. And if you do that math, you'll see that when you multiply this by its conjugate, you're going to get a nice, beautiful answer. And up here, you're going to actually distribute. It's not going to get canceled or anything like that. You're going to end up with radicals still involved. Do you want me to do that, or you guys got it?
Sorry.
That's all right. Yeah, you want me to explain it? Yes? No? Maybe so? Do you want? No? All right. I'll stop. I want to do it. Square root of 3 times square root of 5. Square root of 15. Square root of 3 times 2. That'd be 2 square root of 3. So that's the numerator. Now for the denominator, square root of 5 times square root of 5 is square root of 25, which will take you back to 5. If you want, go ahead and just write that 5. And then when you go square root of 5 times 2, it's going to be a positive 2 square root of 5. But when you distribute the minus 2 to the square root of 5, that'll be a negative 2 square root of 5. And when you distribute that minus 2 to that plus 2, you're going to get a minus 4. And of course, the middle terms right here cancel out because one's positive, one's negative. And 5 take away 4 is 1. So your final answer is really 2 square root of 3 plus the square root of 15. Or the square root of 15 plus 2 square root of 3. You don't really need it over 1.